Hello, my dear students. Welcome back. I know your exams are just around the corner, and this chapter on light can sometimes feel a bit tricky. But don't you worry. In just the next few minutes, we are going to make this chapter absolutely crystal clear for you.
So, are you feeling the exam stress? Please don't, because the whole entire chapter is really just about two simple magical tricks that light loves to play: bouncing and bending. That's it. So if this helps, do me a small favor, yeah? Don't forget to subscribe, share it with your friends, and tell me in the comments what you think.
Chalo bachcho, let's start with light's first and simplest magic trick, reflection. Think of it as light's special talent for bouncing back.
So, what is reflection? It's really simple. Imagine you're playing with a tennis ball. You throw it against a wall. What happens? It hits the wall and bounces right back, correct? Light does the exact same thing when it hits a shiny surface, like your mirror. This bouncing back of light, that's all reflection is.
Now, this is super important for your exams, so listen carefully. There are two golden rules for reflection. First, the angle at which light comes in is always equal to the angle at which it goes out. So angle I is always equal to angle R. And second, the incoming ray, the bouncing ray, and the normal line, they all lie on the same flat surface. And remember, Bacho, these rules are true for all mirrors, whether they are flat or curved.
Okay, so we know how light bounces, but now let's level up the magic a little bit. Let's talk about what happens when we use curved mirrors or spherical mirrors. This is where it gets really fun. We have two types here, concave and convex. How to remember? Easy. A concave mirror is curved inwards, just like a cave. It brings light rays together, so we also call it a converging mirror. Your dentist uses one to get a big, clear look at your teeth. On the other hand, a convex mirror bulges outwards. It spreads the light rays out, so we call it a diverging mirror. You see these every day as the rear view mirrors on cars and bikes. For any curved mirror, you need to know these three best friends: P, F, and C. P is the pole, the center of the mirror. C is the center of curvature, basically the center of the big glass ball the mirror was cut from. And F is the principal focus, the special point where all the parallel light rays meet after bouncing. And please remember this very important relationship. R is always equal to 2F. The radius is double the focal length. Now, I know this table looks a bit scary, but please don't try to just memorize it blindly. Just try to see the pattern. As you bring the object closer and closer to the mirror, what happens? The image moves farther and farther away, and it gets bigger and bigger. But pay special attention to this last case. It's the most special one. When the object is super close between P and F, something magical happens. We get a virtual, erect, and enlarged image behind the mirror. And this is exactly how that magic works. See? This is what's happening when your dad uses a shaving mirror or your mom uses a makeup mirror. The object, your face, is very close to the mirror. So the mirror creates a big, magnified image that appears behind it, helping you see all the details. It's just simple physics that we use every single day. All right, we have mastered light's bouncing trick. Are you ready for the second one? Let's move on to light's amazing bending act, which we call refraction.
Have you ever noticed this? You put a pencil in a glass of water, and it suddenly looks like it's bent or broken right at the water's surface? That is refraction in action. It happens because light changes its speed when it goes from one thing to another, like from air into water. And this change in speed makes it bend. This bending of light is what we call refraction.
So which way does it bend? There's a very simple rule for this. When light goes from a rarer medium, like air, to a denser medium like glass, it slows down and bends towards the normal. But when it goes from the denser glass back into the rarer air, it speeds up and bends away from the normal. Just remember this small rhyme. From rarer to denser, it bends towards normal. From denser to rarer, it runs away. Just like reflection, refraction also has its own laws. The first one is easy. It's the same as before. The incident ray, the refracted ray, and the normal are all in the same plane. The second one is the famous Snell's law. It simply says that the ratio of sine I over sine R is always a constant value. And this constant value is called the refractive index, which is just a number that tells us how much that medium can bend light. So all this talk about bending light, where do we actually use it? Well, we use it in lenses. The spectacles you might be wearing right now, the camera on your phone, a magnifying glass. All these things are only possible because of lenses, which are experts at bending light just the right way. And again, we mainly have two types,
A convex lens is fat in the middle and thin at the edges. It converges light, bringing it all to a single point. A concave lens is the opposite. It's thin in the middle and thicker at the edges, and it diverges light, spreading it all out.
And would you look at that? Does this table look familiar? It should. It's almost exactly the same as the table for the concave mirror. The same pattern is here. As the object gets closer, the real image gets farther and bigger. And look, that same special case is here too. When the object is very close, we get a virtual, erect, and enlarged image. And that, my dear students, is how a magnifying glass works.
Okay, bachcho, let's get ready for the most important part for scoring full marks, the numerical problems. If you can just master these simple formulas and the sign convention, I promise you, you will be able to solve any question that comes in your exam.
This is the #1 rule you must follow, the sign convention. Just imagine the center of the mirror or lens is the origin on a graph paper. Anything to the left is negative, anything to the right is positive. Anything upwards is positive, and anything downwards is negative. It's that simple. Just follow this rule and your answers will always be correct. Now look very carefully at these formulas. They look almost the same, don't they? But there is one tiny difference that changes everything. The mirror formula has a plus sign. The lens formula has a minus sign. Same with magnification. This tiny detail is where many students make a mistake, so please be extra careful. Have you ever been to the eye doctor and they say your power is +2 or -1? Well, that power is simply 1 divided by the focal length. But remember, the focal length must be in meters for this formula. The unit for power is diopter. If you have a positive power, you have a convex lens. If you have a negative power, it's a concave lens. Simple. Theory is all good, but we learn best by doing, right? So let's get into exam mode. Grab a pen and a paper and let's solve a question together. Okay, here's a typical question from your textbook. Read it carefully one more time. I want you to pause the video right here and try to solve it yourself first. Give it a genuine try. Don't worry if you get it wrong. We'll go through it step by step together. Okay, are you ready? Let's do it. Step 1, and this is the most important step, is to write down all the given data with the correct signs. The object height h is upwards, so it's +4. The object distance u is always on the left, so it's -25. And for concave mirror, the focus is also on the left, so f is -15. Step 2, write down the correct formula, which is the mirror formula with the plus sign. Step 3, substitute the values and do the calculation. We find that v is -37.5 centimeters. The minus sign tells us the image is on the left side, which means it is a real image. Step 4, we use the magnification formula to find the size. We get -6 centimeters. The minus sign here tells us the image is inverted or upside down. So our final answer is the image is real, inverted, and enlarged. See? 4 simple steps. And just like that, we have revised the entire chapter. See? Physics is not hard, my dear students. It is just looking at the world's magic and trying to understand its simple rules. You can absolutely do it. I have full faith in you. All the very best for your exams.